Hello everyone, and welcome to our DFIR webcast, Analysis and Correlation of Macintosh Logs. I'm Jason Keeler with the SANS Institute, and I'll be moderating this webcast. Today's featured speaker is Sarah Edwards, Senior Digital Forensics Analyst. Before I turn things over to Sarah, the Q&A portion will take place at the end of the webcast. However, please feel free to submit your questions at any point by using the chat window. Right now, I'd like to introduce our featured speaker, Sarah Edwards.
Thanks for the intro. I'm Sarah Edwards. Let me see how to get the slides moving along here. All right, so a little bit about me. First thing I pretty much tell everybody is that I'm a huge Mac nerd. Absolutely love them, have used them pretty much my entire life. But like Jason said, Senior Digital Forensics Analyst, I am a government contractor. I do a lot of work with federal law enforcement. My primary investigations are usually intrusion analysis with a little bit of counter-intel, counterterrorism, and some things like that. So I have worked quite a few different types of investigations. Unfortunately, I do not get to work a lot of Mac investigations because for some reason Macs don't like to get compromised all that often. But we are tending to see a few more here and there. So why Mac logs? I'm a huge log analysis person. I think they tell a really great story. You can gather a lot of different information from them. And a few of the things I'll be talking about today listed in the slide here. A lot of volume information, network information, and a couple other little tidbits like printing and Bluetooth. While they might not be all that interesting to your case currently working on, they might be very helpful in the future to you. So just the general log locations. Mac logs tend to look very similar to Unix-based systems or Linux-based systems. A lot of the system logs are stored in the /var/log directory. User logs, the tilde is for the user directory. So the user directory /library/logs. And the application-specific logs tend to be located in the application bundle itself or in the system library application support directory. So like I said before, a lot of them use standard Unix format. Most of them are in plain text unless they have already been archived away or they have been rolled over. These are archived in bzip2 compression. And these are pretty easy to find on the hard drive. They're usually in the same directory as the log actually is located with the bz2 file extension. The native application for Mac logs, CONSOLE.APP, is, I find, one of the most conducive ways to look at Mac logs. I've used it a lot for research on my own system and for other systems that I've been investigating. So a little basic things about this application. A lot of my screenshots are taken from this application. So this here is the main window. Right now it's showing the SYSLOGs and or the all messages. Here in this other window we have, a listing of all the logs in the system. So this is pre-populated with the popular log directories. Word of note here is not all the logs will actually be listed in here, so you might have to go and find some of the other logs you might be looking for, particularly about the application-specific logs. And down here in this lower pane, we can see a lot of the log senders. So I think we have listed here firewall, kernel, and applications such as Evernote. Let me quickly go back. So this button right here, the message inspector, the blue eye button, will get you this screen here. So a lot of these syslog messages will have additional metadata associated with it that is not that you can't see when the log is open. So you can right-click the message inspector and view all of the data associated with that particular log entry. Some of the more friendly log software that I've used, CONSOLE.APP, obviously. Some of the forensic software that is Mac log friendly, I guess I could say. FTK, definitely Black Bag, X-Ways, and Text Wrangler, which is not forensic. It's a text editing program, but you can easily throw in a lot of logs and do like a grep search through them, or multiple log directories and search through them too. So I think that's pretty neat. And NK6, not the most friendly, mostly because you have to extract the files and decompress them. But you're still able to view the logical files as they are. So a little bit about BZ2 compression. I use BZCat. It's a native tool on OS X. Basically is cat, concatenate for the BZ files. So shown in the first one, we can see that I use the system to concatenate all the archived system.log files from 7 to 0, 7 being the oldest, 0 being the newest, into one file called system_all.log. The second step I took is to cat the system.log file to that same file. So we have one large system.log that I can go through and grep through as I desire. And while most logs do get archived, these archives don't tend to stay around. One easy way to go and do some log recovery is to grep search for the certain date format that you're looking for. A couple examples are shown here. We'll talk about ASLDB logs, launch CTL logs for audit logs, and the one at the bottom that starts with BZ is actually the signature for the BZIP header, for the BZIP archive. So if you're looking for archive files, do a quick search for that. It's not one of the easiest to find signatures that I've seen. So in 10.8, they made Apple made a major log change. Not quite sure how I feel about this yet, but so before 10.7 and below, there used to be the secure.log, kernel.log, and system.log, each having their own types of messages and things like that. Now everything has been logged to just system.log, which I guess it would make our lives a little bit simpler, but I think it'll be archived and overwritten more often. But I still have yet to do research on how well that will work out for us. So just to let you know, throughout the presentation I do have listings on what can be found in which log, so secure logs, system log, kernel log. But in 10.8, just assume that everything will be able to be seen in the system.log if I don't mention it explicitly. So first log I want to go over is the Apple system log. This is Apple's replacement for SYSLOG. However, it's not quite a replacement. It's really more of a custom version of SYSLOG. So the location of this is in private var log ASL, in the most popular log directory that Apple has. Viewing it with CONSOLE.APP, or you can view it with the syslog command. Shown before in the CONSOLE.APP, there was this one category called all messages. Those are the syslog messages. They just don't call it syslog. If you look at it on disk, you see a bunch of different files with the .asl file extension. Each file name has a different format based upon the date and the user ID and the group ID. And these files are in a binary format. Prior to 10.5.6, which is when they switched over to that format, they used a couple of other different formats. So ASL was introduced in 10.4, but it was in a ASL.log file, which was a plain text file, easy to read, and you didn't have to do any sort of conversion to read it. For a brief period, 10.5 to 10.5.6, they used the ASL.db file, which was a binary format, very similar to the format used now. However, it was just one file. And this uses the ASLDB file header. And it's easy enough to read using the syslog-f command, which is the -f is the option to point it to a file. So syslog command, if you want to use it for more than one file, as I stated previously, you can use it on a file or a set of directories. So for newer systems, we might want to just do all the ASL files at one time. So we'll point it using the -d command. There's a couple of different output formats there. So the standard format is the default format, but I tend to prefer the raw format and or the XML format. And you can play with these fairly easily on your own systems to figure out what's going to be the best purpose for you. And the same thing with the time format. I tend to go with UTC because I do my full analysis in UTC. I have some major issues with time zones, so I like to keep it all in one time zone, otherwise I get very confused. It doesn't really help when I travel either. I have no idea what time it is. But you can also list it in seconds, like epoch time and or a local system time. In the screenshot, I have an example using the syslog command on the directory, ASL directory, and I was just piping it to more, but you can see that this is the default output that you would see. So this is the standard output format. So the command up here, the syslog-tutc, that should be a space between the -f raw and -d ASL. So using this command would get you my favorite output. And I hate to force that upon people, but this is my favorite output. I like the output of the square brackets. It makes it easier to visually see what I'm looking at, and it's also very easy to import into a spreadsheet or grep through, or whatever output format you or program that you want to use for analysis. So a couple of things to point out to you here are the various different types of fields. So these are like level 5. That is the one of the higher levels of logging. So they have different logging levels, and you can read the man pages to figure out exactly what they are. But some of them are warnings, some of them are just, oh yeah, this is just here. You can figure out kind of what you're looking for. So this also has a UID, user ID, group ID, the host name, the sender facility, and a lot of the UT underscore things are just a throwback to the UTemp login data. So next thing we're going to look at are audit logs. Audit logs are from the basic security module. You'll often see these on other secure platforms like Linux. A bunch of different Linux versions, some Unix versions will also use this. These are in the private var audit. This is one of the few directories that are not in those general directories that I stated before, but definitely worth a look at. The audit logs are very loud, very detailed. They can be a little bit overwhelming when you first look into them. So they're named, each one is named by a start time and an end time, shown in the format there. And each one is in a binary format. So a tool that we like to use is PR audit. And I prefer the -x and the -n flags to view them. So in the screenshot here, there is a couple of records. So there are 2 records here. While it may look like more, there's actually 2 records. And I'm not kidding when I say that it's very, very detailed. So the -x and the -n, -x is basically the XML output, and the -n is to not resolve the UIDs and the group IDs. The problem here, or the problem that you could run into if you don't have the -n flag, is that they will resolve to your local host. So if you're looking at a evidentiary logs from somebody else's box on your own system, you'll all of a sudden find your own username in the logs, and most people would be pretty freaked out about that. So here's your warning right now. So the audit logs, they use a variety of different tokens. Each one is made up with a different color in the screenshot here. And they can use a different variety of tokens. This one is a basic one. So you'll find the header and the trailer, so the start and the end. The subject, this one is just showing you that it contains, or it has a certain audit data with it. So the audit user ID, the user ID of whatever event is happening, the group ID of whatever event is happening, and some other information that might be of interest. The text here is one of the tokens that will show you a little description of what the event ID is telling you. So this one is basically saying the password for root is successful. Looking at the return token in blue, we see the return error value is successful. So this is somebody doing an SU, or a super user. Shown in the header up there, I forgot to mention, we see that the event is user authentication. I can imagine that when people are logging in and logging off certain systems, it might be of interest to you. Talking about the tokens, there are more than just 5 tokens. There are, I don't know, upwards of 20, 30 different tokens. And going to the audit.log man page, either through Google or through your terminal, it's a very good description. Shown here is the description for the subject token. So you can imagine all the information that you can get looking at each of the different tokens. Some tokens I haven't even seen yet, and I will have to look at them every once in a while. So let's do some volume analysis. I like volume analysis because it shows you a little bit of history of what the user was plugging into their system or mounting on their system, maybe types of software that they've installed. So SYSTEM.LOG in the screenshot above, we can see by doing a search for /volumes, which is the default mount point in Mac OS X for mounted volumes. So doing a quick search for that in the SYSTEM.LOG show us that we have time machine backups, a volume called no name, that we all have a volume called no name, and a volume called WD Passport. And each one gets a different UUID. Unfortunately, if you have the same volume, you plug it in twice, one right after another, it will have a different UUID each time. So it's unique, almost too unique. So doing the same search for /volumes in the DAILY.LOG, which is the output from a Unix maintenance script, we can see from a little snapshot in time what volumes were mounted on the system. So Friday, May 11th, we can see three volumes were mounted on this particular system. We can see the size of the volume. We can see how much of this volume was used and how much was available. The kernel log and the system log can also show, that screenshot is not great at all. I'm sorry about that. So I guess some of the screenshots will be a little bit squished. I highly recommend downloading the presentation after because they should be much better than this. So I'll try to describe the screenshot as best I can. So doing a search in these two logs for USBMSC, which stands for like USB mass storage device, device class identifier, will come up with a bunch of different, or should come up with a bunch of different volumes with their, quote, non-unique serial number. I say it actually states non-unique in the log itself, and it's just a reminder that this is in fact non-unique. And unfortunately, the one I have highlighted in red you can't see, but it literally is just, the numbers 0 through 9, A through F, which is not unique at all. Otherwise, it would be very interesting. And as I mentioned before, previous to 10.8, the data is found in the kernel.log. Now with 10.8, everything is found in the system.log. A little snapshot from the system information from a live system. So if you happen to be looking at a live system, you can see the mounted data here. We can see a little example of the line there is one of the events that I was describing before. So USBMSC identifier, non-unique, and a serial number that starts with FBF. We can see that the three hex numbers after it, so the 0x90C, the 1000, and the 1100, these are all types of different product IDs, vendor IDs, and version numbers. So a lot of, and this is where the correlation comes in. So it's not just about logs, it's where we can correlate different things too. So one of the property lists that I like to look at is the Finder property list located in the user preferences. Each user will have one of these property lists. So these two different keys, the FX desktop volume positions and the FX recent folder positions, will show you different mounted volumes and what their name is. Fortunately, the hard part here is that it does not give you a time date stamp, so you'll have to figure that out with other different correlating factors. The disk utility property list can also show you some mounted volumes. Shown here in the screenshot is a view of the disk utility with some of the mounted volumes shown there, and the saved disk images list down in that using that key. Each item has its own path to where that disk image was located. The sidebar P lists are basically from the I guess it's the Apple Finder, but some other people who live in the Microsoft world might call it the Explorer window. So on the sidebar there, you'll have the hard drives and various folders and pictures, documents, what have you. But you'll also have your mounted volumes might be shown in there. And this is where they're stored here for all eternity in the volumes lists of the two of saved items and the favorites key. The major difference between the two keys is that one of them lists the applications, documents, downloads, directories as well. But each one you can see that there's basically a history of different volumes that were mounted. So getting into one of these sidebar plist entries, we can see that each one has alias data, which is basically a bookmark, very similar to linked data in the Microsoft world, a volume name, and an entry type. On the left we have a variety of different entry types. Some of them I know, some of them I don't know. If you happen to know the ones that I have listed here as unknown, I would love to have your input on that because I'm slowly collecting this information. It takes a lot of research to try to figure these out. And of course you have that one that you can't figure out. It's there, we don't know why it's there, but it's always there. So a little quick at the volume alias data, we can see it's in binary, so we extract it, throw it in a hex editor. We can see H+. Now H+ is the volume format for HFS Plus drives. This might also have BDXF, BDIS for Windows-based formats. And again, there's NTCU, which as far as I can tell, I don't know what type of format that is yet, but I have seen the record in there. And fortunately with HFS volume formats, we can see that they have file creation or volume creation times, which could be very helpful to you to see, when was this volume created. Might help your timeline just a little bit more. So now we work on to network information. This one is one of my favorites. So just doing a quick look for in SYSTEM.LOG for different network changes, we can see different things like what the host name is set as, what Wi-Fi networks are configured as, and when the network has actually changed. This is more seen with laptops rather than desktops. Desktops usually don't attempt to change networks all that often, but laptops do, because that's kind of the whole point of a laptop, is to be mobile. So you're connecting to different hotspots here, there, and the other place. So if we do a search for airport D in the system log, we can see a couple of the hotspots and or APs that this system was connected to. We can see Veyron, Panera, and it attempted to connect to LA Boxing customer Wi-Fi. So it doesn't quite look like a successful connection, but it does appear that they have attempted it. So the airport preferences property list will show us the last connection time of a particular hotspot. So in the example, we have the Panera hotspot. So this was last connected June 12, 2012. We can also see a couple of other things, whether it was captive, meaning, did you have to input a code or a username into that little window that pops up. So we see yes, it was. Security type open. So while it is captive, the security type is still open. And we can see that with the remembered networks, I'll go over this a little bit later, that there are at least 5 different networks that this system has remembered. So the network identification, this can be correlated back with the previous property list, but this has a lot of the network configuration data. So it has the routers going out, the IP address that it was associated with, and again the timestamp of when this was last updated. So determining a home network. This is really more of an art than a science. So maybe in an investigation you might want to know what network is this person's either home network or business network, let's say. A couple of things to help determine that is in the airport preferences list that we've already seen, we can see item 0. So item 0 is going to be the first network that the computer was set up with. I figure most times a person is going to set up their laptop when they first break it out of the new box, a shiny new Mac's coming out, that they're going to set it up either at home or at work. And it's likely going to be in the place that they're using it most often. So my home network, or the first item 0 on my home network, is my AP at home. Since I bought the computer, I brought it home, set it up, and everything else. Say you're given a laptop at work, it's probably going to be set up with the Wi-Fi or the network that you have at work. Generally speaking, and I hope this is true for everybody here, the security type should not be open. We should all have some sort of security on our systems. For example, mine is a WPA2, so that can help you see if it is in fact a closed network. And one more thing, we can look in the system logs, and this is basic investigation right here. What AP is used more than anyone else? So that might help you figure out what is your home network. And I mention this because I'm going into locational data. So trying to put the computer at a certain place at a certain time. So different wireless networks, they broadcast their SSID, and it's usually, maybe it's an airport, or it's a hotel, or it's a restaurant like Panera. You can try to figure out where these places are just by the SSID name, unless, of course, somebody's trying to be malicious, and, well, you just have to deal with that later. So in the screenshot, I mentioned earlier about remembered networks. So in the left-hand screenshot, we have here all the remembered networks. In most cases, if you look into your system right now, you will be amazed how many different access points you have used in the last, basically since you set up your system. As far as I can tell, they never get wiped out. So, I mean, good for us, right? We get a lot of informational data that way. So on the right-hand side, we see the airport preferences property list, and I've highlighted a few of the different access point information there. So we'll get into this a little bit more detailed in the next slide. So if we take those different items from that property list, we can almost make a little travel timeline. So the first box, I have Veyron, which I've already assumed is my probable home network. So from Veyron, this computer went to Washington Dulles Wi-Fi. I'm going to guess that it's an airport Wi-Fi. I could probably verify it if I go there. Some of us are probably closer than others. So maybe this person's doing some travel. Maybe they're just picking somebody up. Who knows? So go to the next one. We see that it's Marriott guests. At least that's the SSID. Maybe they are staying at a Marriott. Don't really know where, but we might be able to find some other information on the hard drive that'll tell us this. Next one is a Marriott conference. Maybe the same Marriott, maybe a different Marriott, but perhaps they're attending a conference at this hotel. And the very last one, we see CLT.net, which doing a quick Google search, we see that this is the Wi-Fi for Charlotte Douglas International Airport. So it does look like that this system traveled at some point. So we want to take a little bit more look into what activities this person might have done, if that's of interest. A little bit more detailed view of that, we can do an airport D search in the SYSTEM.LOG, and we can see the exact times that this person connected to a specific access point. So in the screenshot here, we have Veyron at a very specific time, Washington Dulles Wi-Fi. June 2nd, Marriott guest. June 3rd, Marriott guest. June 4th, Marriott guest. Looks like they check their email daily. And June 6th, we have Marriott conference. Then we have CLT.net, so it looks like they've come home, back on Veyron, so they're home for a little bit. And it looks like they needed a bite to eat, so they went to Panera. Ooh, this screenshot doesn't look great either. So this is easily one of the best parts of some of the log analysis here. So what's better than local or CONUS travel? Oh, CONUS travel. Access points have this code that they like to distribute, some 802.11 regulatory thing that includes country code information. So unfortunately, each one of these blobs of color, wish you could see it better, but each one shows different channels, Wi-Fi channels that are allowed to communicate with. But each one also shows a country code. So I'll describe it as best as I can. So the first one in red has the country code AU, which can, if you don't know, can easily be looked up. It's Australia. The second one in purple has the country code X0. Now this is not a country code, it's more of a, hey, I don't quite know what the country is yet, I'm looking for it, or it hasn't been set up yet. So it's kind of like the default code. In the green, we see that the country code has been set back to US. And in the blue, the country code is set for SE, which, looking up, not just my initials, also Sweden. So this computer has been doing some serious traveling, getting some serious airline miles here. But we can see with the dates and things when they traveled. Only in 10.6 have I found this. I have not seen this in 10.7 or 10.8 yet. If we search for the host name in the system log, we can get some more identifying information for travel. A couple of the examples are shown here. We have DIA, which is the Denver Airport code. LV, we can guess. It's probably Las Vegas. We could do some quick internet searching too for that. And if you look at the last one, if we search for the IP address, 7864, it appears to be registered to a ISP in Sweden. So we can attempt to verify this type of information. So what can we do this correlate this with? Tons of things. Photo exif data. Can we look at this person's vacation photos and attempt to cross-correlate that? Calendar items, travel websites. Are their travel itineraries set up or sent through their email? Things like that. Next topic up is user activity. So one of the biggest things for user activity is to figure out when the user was on the system. This can be seen with logins and logouts. So OS X has at least 4 different types of ways to get onto a system. The local terminal, which is the terminal program, terminal app that is used, will have the entries shown below. Login window is the normal GUI login window that everybody with a Mac will log into. SSH, if you want to use the OpenSSH client, you can also use that. And there's also screen sharing, which is basically a VNC type of program used for Macs. So other than screen sharing, each one of these events has a underscore process associated with it. So user underscore process is a log on, and the dead underscore process is a log off. So we can see what the process is, so the number after the process. So shown in the first one in the local terminal, we see user process 693. So that's the process ID of the process logging that particular person in. We can correlate that back with a dead underscore process called 693. We have here a user process and dead process for the process 812, so we know exactly how long that particular terminal was used. As a note here, every time you open up a terminal window, it is a separate login session. So you'll have a user process until you close that session, in which case you'll have a dead process. For screen sharing, it's a little bit different, and it gives you a little bit more information. But we can see that you can see the user ID, Sarah Edwards, me, and what IP address they are coming from. Now, these user logins and logouts can also be seen in the SYSTEM.LOG files. And those will have a little bit more detailed information, such as what the user is, the time, and possibly some more information that might be of interest to you. So it's definitely worth not just looking in the SYSTEM.LOG files, but also into the SYSLOG files. So another Unix maintenance script in monthly.out file has a this nice little accounting feature to it. So it does a AC-P command to calculate the accumulated connected time in decimal hours of a particular user during a particular month. So on the screenshot on the right, first thing I would see is, why is root even on here? By default, root is not enabled on Mac systems. So that first would be a giant red flag to me. So, okay, interesting. So let's take a look at May and June. We see that April and May. We see that root is being used a little bit more often, but then they stop being used over in June. But we see that the user, SL Edwards, uses the system primarily. Privilege escalation. Doing a lot of intrusion exams, I'm very curious when somebody needs to use various administrator accounts. Now they definitely can be used legitimately, but be aware that these are a couple of the items that can be used to escalate someone's privileges to root. So SU can be used to escalate your privileges for the terminal, or for the amount of time until you close that terminal out. The first example shown is a bad SU, meaning they did not have the password correct or they didn't have the username correct. The second one shows a successful SU to root. And we also have sudo, which is basically privilege escalation per command or for a few commands during a small time period. We can see that the Oompa user account tried to escalate their privileges using root, and we see what directory they were in, and also the command that they were trying to use. So some good information there. Now, account creation. Going back to the audit logs. Like I said before, it's very detailed. Just showing you one record here, there's probably 50, 60 or more different records that get logged just with the one action of creating a user. So an event in the record, we see the event called create user. You could easily do a search for this type of event. And in the subject token, we can see that the UID that created the user is 501. So likely the first account, first non-admin account on the system. We can see that the user account created was called super secret user. So a lot of good information there. Also, just to show you what is shown elsewhere in the secure log or system log, when you create a user, not much is logged. You'll have this little thing that says authenticated user OOMPA for right to system preferences accounts. So it doesn't really quite tell you that an account was created, but keep your eye out for things like that. And also make sure you look at other logs such as the SYSLOG and the audit logs, because many of those will be more detailed. Excuse me. So the account deletion. Naturally, if account creations are important, account deletions are also could be of importance. So the accounts preferences plist will show you all the deleted users for a particular system, each in their own item slot. This saves the real name of the user ID. This one is shown as 502, the account name, and the date that the user was deleted. And another audit log record shown below, we can see the event delete user. And we can see that the UID of 501 deleted the user, and the user was called test user. So on to backups. Many forensic analysis likes backups. It means we can find more data elsewhere, maybe. So if we look in the system.log, and I will try to describe this one as best as I can also. So each backup starts with starting standard backup and backup completed successfully, assuming that the backup created successfully, with some other information in there. So when the backup started, the network location of the backup, or the local hard drive. You can also use a USB hard drive to back up to. The mount point, amount of data backed up, the volume name, deletion of previous backups, and when the backup was completed. So the time machine plist, which is the program used to do the primary, the native backing up of Mac systems, can be shown here. So we have the time capsule name. So my time capsule is called DeLorean. Waiting for somebody to laugh at that. Come on. And we can see that there's backup alias data. So if we extract that data and put it into a hex editor, we can see that the default username is for Sarah Edwards. You can see the path there. AFP is Apple Filing Protocol if you're interested. And we can see some other data such as the volume UUID, and if it's set to auto backup. The other time machine plist is the time machine snapshots plist. This will show you when each snapshot was created, and it can go as far back as to when the time capsule was originally installed. So you can have a huge variety of different snapshots to look at, especially if you can get a hold of the time capsule that is associated with it. So the software installed on the system could also be of importance. So we'll take a look at that. Apple has this great log called INSTALL.LOG. So it shows you exactly what was installed and when. If we do a search for just the term installed, we can get a nice little listing and dates and times of when each package was installed. And this isn't just for system packages, it's also for user packages. So in the screenshot, you can see when I installed Evernote, when Xcode was installed, and when I updated the machine to 10.7.4. So we can see when the software update is last happened or last tried to happen. So the last attempted date key shown here shows when the software update program tried to update the system. And we can see the last successful update there, which is June 14th. We see also the system version that has been updated as well. The install history plist located in library receipts has a whole lot of information about each package that was installed, such as the date that it was installed, what was the package name, and the process that installed it. So normally for user installed packages like Wireshark, Evernote, Text Wrangler, you'll see the process installer. If it's a system update, you'll often see the process name software update. So item 36 shown below, I installed iTunes 10.6.3. You can see software update was the process. And in that same directory, we have a list of different property lists and a .bomb bill of materials for each package that was installed. So if you look at the property list, we can see a lot of the same information, the package identifier, the install date, and what the install process is. And the bill of materials basically shows you what files were installed. Again, going back to the install log, we can see that when the package was installed, where it was installed from, so downloads directory. Did the administrator have to input their credentials to install it? Yes. And we can see that eventually it did get installed a minute or so later. For those interested, logtext is an open source keylogger for Mac OS X. Could be useful, just saying. Now if we look at the install log again, do a keyword search for build, we can see what version of Mac OS X was running at a particular time. So we can see when various updates were performed. So May 9th, I was running 10.7. On May 11th, I finally installed the update and installed 10.7.4. And the same thing can be done if we search for Darwin in the kernel log. Each time the system boots, they will have this one entry showing which kernel version is being run. And each version can be mapped back to a particular OS X version. So I believe kernel version 11 is 10.7 and goes upward from there. Now, different state of the system could be important. So when the system was booted, when it was shut down, when did it reboot, things like that. Shown here is a couple of screenshots from SYSTEM.LOG showing you when the system was booted, so we can search for the term boot_time, and the time, either the time to the left or the time to the right, whichever one you prefer. Will show you when the system was booted. So the times on the left are local system time, while the epoch time on the right is the Unix epoch time that can be later decoded using your favorite tools, either decode or the date command, what have you. And in the screenshot below, we can see when the system was shut down and by whom. So if we do a search for just the term shut down, we can see the shutdown time, which looks very similar to the boot time. We can see that who shut it down. So halt by OOMPA means it was shut down by the user OOMPA. We can also see the term reboot by OOMPA. So that means it's going right into a reboot. So in the kernel log and system log on 10.8, we can see when the system was booted just by looking at a couple of these entries. So there's maybe 30 different entries when the system boots up, showing kernel version, showing network information, showing boot volume information. So to find the start of that, look for on 10.7 PMAP with PCID enabled, or on 10.6 look for NPV hash. And these are two screenshots. The first one is 10.7, and the one below is 10.6. So you can see that there's a whole lot of information there. So I'll be going through that. So this boot information can also show you some hardware information, which might help you a little bit later on if you're trying to figure out what kind of system did this machine come from. Shown here, we can see that the system has a few different processors. So this is an example of two systems. Each has one physical processor with 2 cores. RAM size might help you try to figure out what type of system this is coming from. So shown in the kernel.log or system.log, we can see the var VM sleep image. We could do a keyword search for that, and the size that I have highlighted there is the size of the RAM. So the sleep image file is basically like a hybrid file on a Windows system. So this particular one is 8 gigs in size. So boot device might also be of interest to you. So if we do a search for things like boot UUID from chosen, we can see the volume boot UUID. We can also see, if we go a little bit further down, we can see the type of media that it was specifically booting from. So doing a quick Google search for the data highlighted in blue, we can see it's a Western Digital drive. Also happens to be 750 gigs. So this might be important because Mac Pro systems tend to have their hard drives switched in and out, depending on if you're in an environment where people like to take hard drives out quite often. Doesn't really happen with laptops, just because it's a little bit harder to get to. But we can see that a system might have been booted from different systems. So in the screenshot here, we can see the boot UUID from an IO-reg output. And we can see in the screenshot above, we can see when it booted and what the volume UUID was. So say this person you're investigating has a hard drive and they're booting it from various systems. We can see this. So we can show this by the various MAC addresses and the different volume UUIDs. So every time you boot from a system, say we have 3 Mac Pros with 1 boot drive, we can put it in 3 different machines. It will all have the same boot UUID. That doesn't help us so much. But when correlated with the MAC addresses, we can see that it did hit 3 different machines. One uses a Yukon Ethernet NIC, one uses a Broadcom, and another one uses a slightly different Broadcom. But we can go attempt to find these different machines if need be and cross-correlate that with what NICs are installed with them. This is something I actually had to do on a case, so it was kind of interesting to me that a hard drive was traveling around an office. And I was able to find each machine that it traveled to, which was very important to the client. So system boot and shutdown cause. This is logged each time the system is shut down. And just like the data we had before, none of this is detailed well. Apple developer does not detail this out as far as I can tell. So a lot of this was research. The normal shutdown and reboot is a number 5. And you'll pretty much see this unless you have some issues. The hard shutdown, when your computer just won't quit, you just hold down the power button, it'll be a shutdown type 3. And if the battery just dies or the power plug is removed, that should be a shutdown type 0. And the same thing if the system is put to sleep. More or less done with laptop systems. A normal sleep, when you just close the laptop lid, is a number 5. And hibernation is a number 0. And when the system is awoken, we can have a bunch of different types there. So there's a lot of different functions that will wake up a laptop or a system. Opening the laptop lid, attaching the power cord, using the trackpad, plugging in a USB drive. All of these can wake up a different system, so that might be of interest to you as well. So disk usage. We might need to find out how much was this disk used? Was it used fairly regularly? And we can go back to the daily log shown before and look at how much capacity, let's say, or how much disk usage was done over a period of time. So the daily log gets run daily, so we can take a snapshot from each day, correlate that together. That's in the inset screenshot to see, oh, okay, this particular drive was 16% usage, now it's 26% usage. What happened during this time period? Now a little tidbit that some people might find interesting is printing. So Macs use the Common Unix Printing System, or COPS, which is a very Unix printing system, and it records all the data shown here. So what the printer is, date and times, the job ID, number of pages, the system host name, and the little bit of metadata about the print job. So the job name, which is usually the page title or the document title, what type of paper did it use, letter size, legal size, and the size, whether it was one-sided, double-sided, or what have you. The access log will show you how did this print job work out. Was it successful? Did it create the job? Did it error out? Was this person able to print what they wanted to print? Those printer job IDs can be cross-correlated with the printer control jobs. These are stored in the var spools CUPS directory. Each one has a different job ID associated with it. So C-0001 is the first print job, and that would be associated with job ID 1 in the printer log. And these files just hold a little bit more metadata about the print job. Might be useful to you later to figure out what types of files were printed at a certain time. Now the neat thing here is that there's also data files associated with the printer control files. Similarly named, so D0010 is print job number 10. So these are actually PDF files of whatever was printed out. Unfortunately, they are immediately removed after a successful print. But if the person does have an issue with the printer, they can't print, the PDF files will still be there until removed either by the user or by the system at some future point in time. So you might want to do PDF carving to see if you can find any PDF set of things that were printed out on a system. And temporal changes. People like to mess with their systems, see maybe they can try to hide different things by changing the system time. So I just wanted to show you in these terrible screenshots, again, download the PDF of what the system time changes will look like in the system log. So if you do a search for system preferences, you can see in the screenshot that the system time was changed to go back in time. And highlighted, we can see the timestamps. So it looks like it was changed 3 hours previously using the system preferences date and time preferences panel. Looking at the link for Etsy local time, we can see that the time zone, see what the time zone is set as and when it was last changed. So for example, here the time zone was last changed to LA time on June 16th. And going back to the future, we can see that this person tried to change the time to the future, so it just jumped 3 hours ahead. And it looks like with the geo world time that they did it using time zones. So these things are things you need to look at, be aware of. And again, in the daily log, this is quite the helpful log. We can just do a search for maybe whatever year we're looking at, or whatever is in our scope of work. In the example shown, we have 2012. So we can see that the time zone was changed from Eastern Daylight Time to Pacific Daylight Time. So maybe they changed because they were traveling. Maybe they changed because they wanted to be malicious, or maybe they changed because they just have no idea where they are at that point in time. So some of you may have noticed that a lot of these logs do not record the year. It's a very Unix thing. It's also a very frustrating thing. So a couple of ways that you can bring some context into the log file that you're looking at. Maybe these are maybe these are fragments that you have carved out of free space, or otherwise have been archived, and you have maybe the MAC times are all screwed up on them, what have you. So we can look in the context of this particular log, either before or after a certain entry, to get an idea of when this particular event happened. So be on the lookout for different epoch times. A bunch of them are highlighted here. Different time formats, different shutdowns, because those are always going to be stored with an epoch time. Backup times will also have dates, and even applications that are probably crashing at this point will also save the date. And the last section. Sorry, this is a very long presentation, but I hope a lot of this is helpful to you. I do tend to do long presentations so you can download them and use them for your analysis later on. So the last section is Bluetooth. Through this section and a little bit later, because I thought it was really interesting to see what types of devices could be connected to systems. So a lot of the Mac systems these days have Bluetooth completely installed. You can hook up headphones, keyboards, mice, your Magic Trackpad. Love that thing. Got to have it. So if we do a search for BlueD, the Bluetooth daemon, we can see the MAC addresses of all the Bluetooth devices that were connected to this particular system. And we can correlate that with the Bluetooth property list. Shown here, we can see in the device cache, we can see what devices were connected. The class of device shown here, 9536, can be reversed back to figure out what type of device it is. Now 10.8 has updated this property list a little bit and has given a whole lot more information. So we can see the name of the device, Logitech Boombox, when it was last updated, when it was last queried, and different services and other Bluetooth type information. But it still does have the class of device associated with it. And to reverse that, I'm not going to go into that today, but you can be sure that this information is stored on the system using the header information in the path shown there. So we can use this information to reverse back of what type of device it is, whether it's a, is it a keyboard, is it a headset, or is it some sort of Bluetooth storage device. Some of these might be more important than others. And that's all I got for today. I hope you enjoyed it. If you like this stuff, I'm a huge Mac nerd. I was asked to put together a SANS class, SANS Forensic 518. It's going to be a Mac class. So yay Macs, and I hope everybody's excited about that.
Thank you very much, Sarah. And we did have a couple questions. Our first, when will SANS release the Mac Forensics course?
When I finish writing it. It's really up to how fast I can create the course right now. So, but be assured that there will be marketing done for that.
Thank you.
So you'll know.
And our final question, can you recommend any books for someone who's new to Mac forensics analysis?
Let's see, there hasn't been a recent book, but an older book done by Ryan Kabasiak is a good resource. It's a good starter. It's not the most advanced, but it'll definitely get you the gist of what you want. Some of the Linux forensics books are also good because a lot of it tends to be related and similar. But other than that, there's no real forensics books. However, you can find the Mac OS internals book, and there's a newer Mac internals book that just came out a few months ago that's got some really good information, very technical information. So it might be too technical for a normal forensic exam.
Thank you so much, Sarah, for your great presentation and for bringing this content to the SANS community. To our audience, we really appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, please visit sans.org/webcasts. And until next time, take care, and we hope to have you back again for the next SANS webcast.